That's what I get.
Hums? Hums?
Yeah.
Where is your video?
Hello?
Hi Anish, nice to see you today.
You too.
Can we wait for a few more minutes? I think everybody forgot the class.
Yeah, but in this case, how to cite A and B? You know how to use Google?
Yeah.
Then do it.
Yeah, but Google isn't always right because there are like 9 different.
So you know what your answer is? No. You know what the answer is?
What?
You go to Purdue OWL. Has really good resources on citing things. Okay? You look for anything that says .edu.
Yeah.
Because what does that mean?
It's a website meant to teach people about things.
No, that means it's from an educational institution.
Okay.
So, yeah, technically it's that, but like, yeah. So you get it. Now you have all of these resources on how to cite things.
How are you, Ritisha? What are you doing in school, Ritisha, now?
We're currently doing, I think, polynomials and like factoring out polynomials basically.
Is it easy?
I don't understand why you can't.
The binomials are easy and we're learning like the ones where like what's it called? Where it's like ax squared plus bx plus c.
So include the name.
Is that hard?
So you bet.
No, our teacher taught us like this trick and it works really well, so.
For factoring?
Seems like you did.
It's for factoring out and like finding two
And then say,
like binomials that equal the polynomial.
But my question is, are you able to use what we learned in class?
Yeah, I'm mostly able to.
Okay, that's good. That's good. I just wanted to know.
Hi, Priyanti.
Hi Vidyut. Hi Swarit. Hi Diya. I have a couple of questions to each of you. Have you all learned logarithms?
yeah.
Not yet, right?
Not yet.
Okay, that is one question. Second question is, have you come across special functions like piecewise functions, absolute value functions, ceiling floor functions? Have you come across all that? Yes, no, anything is okay. I just want to wrap up
What's a
algebra
ceiling floor function? I don't think I've learned that one.
Don't think you've learned others, right?
I learned like piecewise and the others, but not ceiling floor function or whatever that was.
I learned only absolute value function.
Okay. Okay, let's see. I just want, meaning, before I move on to that, right? That's what I've planned for today. Okay. Did we go over inverse functions, guys? That I want to check. Did we go over inverse functions? Did we go over inverse functions? I have to check. You want me to check?
Yeah.
But do you remember inverse functions?
Not really.
Not really. Ashwik, do you remember inverse functions?
No.
See, Those are the topics that I want to finish and cover. After and I want all of you to buy the geometry book, guys.
This is painful.
Geometry book. Do you all of you have it?
It's arriving.
It's arriving. Okay. So within 2 weeks it will arrive, right?
Yeah.
That's better.
Okay.
I have it.
You have it. Okay, that's nice to know. Okay, that's nice. Nice to hear your voice, Nish, in class.
Yeah.
Okay. I just wanted to know inverse functions. Definitely you have to know, guys. I cannot go without it. But let's see. Okay. I feel like we did it though. But anyway, I'm going to check on that after class. If you don't remember, there's no point for me to go forward as well. Suppose, let's say I have a function f of x equal to 3x minus 2. Okay. Now, can you find the inverse of the function? Means, let's say, okay, one thing is, what are inverse functions? First, you need to understand. Okay. Before I go to algebra side, okay, there are two ways of finding it. Okay. First, what is an inverse function? We'll see. One is an algebraic way of doing it. The other is the graphical way of doing it. Okay. Now,
Yeah.
let's say you have the u. What is this function?
Everything after it.
What is this function? Parabola. You know what is the inverse of it? Okay, how do I do the inverse? What is an inverse function? Now I say this function is f of x equal to x square. You're all with me? Now you know what I'm going to do? What is this line equation called? What is this line equation called?
Y equal to X.
Good. That line is y equal to x. Y. 0, 0, 1, 1, 2, 2, 3, 3. You see what I mean?
Yeah.
That line equation is y equal to x. Now, think about, for the parabola, I'm going to split it into part by part by part by part. Okay? And I'm going to reflect it on the line y equal to x. So this part, if I reflect it on the line, this becomes this. Makes sense, guys?
Yeah.
I'm splitting up into parts. This part, if I reflect it, it's going to become this. Does that make sense?
Yeah.
Now, again, I'm going to split it into piece, right? What about this part? If I reflect it, it will become this part. Did that make sense? So, the function that I got now by reflecting is this. Do you all agree with me?
Isn't that kind of like a square root function?
Yes and no, but first of all, did you understand how I got that?
You reflected off y is equal to x.
Yeah, I reflected, I split the function part by part, piece by piece by piece. And then I reflected on the line y equal to x and I got this. But again, that function when I reflected it, this is my original parent function. This function that I got now is my inverse function. But is it a function first of all? Is it a function?
No.
No.
Clearly no, it fails a vertical line test. So you know what I do? I go to my original function. I'm not happy. I go to my original function. I restrict the domain of my original function. I say, hey, I'm going to restrict the domain of my original function and I'm going to have only positive values of x. Now, I said my original function is this only. You got it? So, my inverse function got just this. You see what I mean? I made my inverse function a function by restricting the domain of my original function. Does it make sense? Does it make sense?
Yeah.
So this being the case, right, now this was a square function, correct? Did you see this is a square root functions graph? This is a square root functions graph. Now do you see what is inverse functions? Graphically, it is just the function reflected on the line y equal to x. Does that make sense? A very nice example is a square function becoming a square root function. But how did it become a square root function? By restricting the domain of the original function. Make sense? So, what is the domain of the original function? What is the domain of the original function? 0 to infinity. Correct, guys? 0 to infinity. 0 is a point on the graph. Then I use this brackets. Infinity, you cannot touch infinity, so I use parenthesis. Make sense? The starting interval, the ending point. What is the range of that function? It is again 0 to infinity. Make sense, guys? Does it make sense? Now, what was the range of the domain and range of the original function? Meaning before restricting the domain. Minus infinity to infinity. And then what happened? Range was 0 to infinity. Are you all with me? Are you all with me? Now, one thing very interesting about this is function and its inverse interchange their domain and range. It's very interesting. I'll tell you how. Let me look through. This is 3x minus 2, right? How do I draw this? Can I put 2 points? What are the 2 points? Can I put 0, 1, 0, minus 2, right? 0, minus 2. So this is a point in the graph. In this graph, okay, this is my original function I've given you. Then the second point, what can I do? I can put y equal to 0. So 3x will be equal to 2, x will be equal to 2 by 3. X will be equal to 2 by 3. 2 by 3, 0. Then this is 0, minus 2. So this is my original function. You're all with me, guys? Now I'm going to find my inverse function. I'm going to find my inverse function. When I reflect it on x equal to y line, right, I will have to split the function. Otherwise, I don't know how it will work. Okay, this part will become this part. This part, see, this part will become, when I reflect it on the line, right, it will become this part. Am I making sense, guys? Am I making sense? If you reflect this line, you have to split it and reflect. This part will become this part. This part will become this part. Does that make sense?
Yeah.
So this is f of x. This is f inverse of x. Am I making sense? Now, let's make it very easy. Y equal to x. What will be the inverse of that function? This is the function.
Y equals x.
Okay, you cannot reflect this, right? Okay, let's continue this itself. Y equal to 3x minus 2. So what will be the equation of the reflected function? How to find it? I will draw this again, guys, if you need. Okay, I'm going to erase this and I'm going to only consider 3x minus 2. So as you said, right, we found out 2 points. What were the 2 points? 0, minus 2. And then what was the other point? 2 by 3, 0. Does it make sense? Okay, now I have to find the inverse function. You know, algebraically I'll show you how do I compute it. Y equal to 3x minus 2. Correct, guys? That's what is given, right? The first step is to switch x and y. Switch x and y. X will be equal to 3y minus 2. Second step is solve for y. That's all. solve for y. X plus 2 divided by 3 equal to y. So f inverse of x is x plus 2 divided by 3. Makes sense, guys? But what is that function? Meaning, what is this function? Y will be equal to x plus 2 by 3, right? What is that function? Basically, 1 by 3x plus 2 by 3. Correct, guys? So, what will be the points? Think about it. Put 0 here, x equal to 0. What happens? Y equal to 2 by 3. 0, comma 2 by 3. 0, comma 2 by 3. See what is happening to the points. Then you put y equal to 0. Then what happens? X will be equal to minus 2. Right? So, minus 2, comma 0.
So the numbers in the x and y intercepts change, like they switch?
Exactly. So, the x's become the y's become the x. Do you see it? Dia, are you following Dia?
Yeah.
So I see, I really want you guys to understand, we are discussing inverses, Shyam. Okay, inverse of function, inverse functions we are discussing. Okay, so I want you to really understand, if I give you a function, I plotted, this is my function. Okay, and then what I did algebraically was, first step I switched x and y, and then I solved for y, that is the inverse function. Make sense?
Yeah.
Now, this is the inverse function. So basically what is the relationship? What is the relationship between f of x and f inverse of x? So when I did that, my graph became this. You see? My 2 by 3 comma 0 became 0 comma 2 by 3. 0 comma minus 2 became minus 2 comma 0. Do you see? So in my inverse function, the domain becomes the range, range becomes the domain of my original function. Make sense?
Yeah.
So suppose if I say the domain of this original function is, let's say only 2 points I'm considering, guys. Okay, I'm not considering every point. Okay, domain of the original function is 2 by 3 comma 0. I'm not considering every point, please. Okay, I have to consider every point, but example I'm saying range is what are the 2 points I have? 0 comma minus 2. This is the original function. See what happens to f inverse of x domain. Domain is 0 comma minus 2. See, it exactly changes. The range becomes a domain here. And then the range is 2 by 3 comma 0. Makes sense, guys? Just that they get switched. The domain will go to range. Range will become the domain. Makes sense? Do you understand how to calculate it algebraically?
Yeah.
Yeah.
Now, graphically, when you look at it, right? Graphically, the original function is reflected on the line y equal to x to get my inverse function. That is why I said, think of the line y equal to x. Shyam was not here when we discussed this. Original function, what was the original function? The original function was this, right? So that, when you reflect it, it became this. Now the second part of the line, this one, when you reflect it on that line, became this one. So my f inverse, this was my f of x, this is my f inverse of x. Make sense? Anish, are you following?
Yes.
For you guys, a lot of algebra 2 will be easy. This is a concept in algebra 2. That is why I postponed till this date. You got it? Are you guys getting? Let's see this one. They are just introducing to you, but at the same time, they have inverses being discussed. Okay? So, I really want to help you understand that. Let's see. Okay, they have given f of x is the inverse of g of x. You are going to find out, guys. Okay, g of x is equal to 2x minus 3 by x plus 5. They are giving easy ones for you in Algebra 1 book. Now, find out f of 4. You know, please understand f of x is equal to g inverse of x. This is how inverse is written. One thing what I don't want you to confuse is f of x, f inverse of x. F inverse of x is never equal to the reciprocal function. You got it? This is a reciprocal function. This is the inverse function. Both are not equal. You got it? For one, let's say 1 multiplied by 2. 1 divided by 2 is an inverse function, I would say. Do you get it? But it's not a reciprocal function. You get it? Don't take it as reciprocal. Reciprocal is not correct. This is an inverse function. Okay, inverse function graphically means you're reflecting the graph on the line y equal to x. Algebraically, what do? You switch all your x to y, y to x and solve for y, which is the inverse function. Now, can you find this and tell me, guys, what is the value of this? Quick, come on, please. Anish, I really want you to answer. Otherwise, work it out on the board. Come on, guys.
Okay.
Come on, guys. I really want to first of all, send me what is f inverse of x. I'm sorry. First of all, find out what is f of x. G of x is given. What is f of x? Tell me. Try, guys. If you don't understand, I'm here to help. Sorry, guys.
Miss Priya, is that my answer?
Yeah. Madam. done, guys?
I
Can
put my answer.
Yeah, I have.
I did the 1 by fx thing.
You did?
Yeah,
What is that?
I did the 1 by fx thing.
1 by f of x is not the function, is what I told, right, Anish?
Yeah, like I just did that one. I'm gonna do f4 thing too.
I really want f inverse of x.
Wow.
That's what I've been telling and telling and telling. F inverse of x is different from 1 by x, right, Anish? 1 by f of x. That's what I told you, right?
Yeah. Okay. Sorry.
No problem. As long as you understand, I'm happy, Anish.
Yeah.
With you, that's right. With you, that's right.
Auntie,
Yeah,
is
tell
there
me.
a quicker way of finding the inverse without like replacing the x and the y?
Why do you ask me like that? Correct
I'm
one.
just asking because like you need maybe if you just switch, there's like another trick to find out the inverse.
Actually, no. 23 by 2, ma. Minus 23 by 2. Ritisha, can you check for f of... I feel like, Ritisha, your denominator is incorrect. 5x plus 3 by 2 minus x, ma.
Wait, can I first tell you what I got for f4 and then can I do
Yes,
F4?
Anish, so nice of you to hear your voice. Tell me.
Okay, so should I type it?
Yes. You can shout it out. I have got answers from everybody. Dia, did you get it, ma? Please don't make it me ask individually, guys.
Yeah.
I got, can I say?
Yes.
I got negative 23 by 2.
That's right. Good job.
Yeah.
If you answer like this, I really like it, Anish. Honestly. Dia, did you get it, ma? Yes, you got it. Okay. You guys all understood inverse functions well? Then what? No. Yes. Okay.
No,
how
I'm
about-
still a little bit
Yeah,
confused.
you don't need to know everything about it. What will be the inverse function of this? This is not in your book. I'm asking you. What is the inverse function of this?
The cube root of y.
Yeah, just change it. Take cube root on both sides. Y will be equal to cube root of x. Did you get it, guys? It's an interesting, you know what you learn in algebra 2, you're thinking. You learn linear functions again, you learn quadratic functions again, then you learn the inverse of this, then you learn the inverse of this, then you'll go to cubic functions, then you'll go to cubic functions, you'll find the inverse, cube root functions you'll learn.
Decrease the height of this table.
Here it's the square root function you'll learn. So you'll finding inverses in algebra 2 for each of the function you study. You'll study logarithmic, then you'll study inverses. Exponential function are the inverses of logarithmic functions. So each function, whatever you study, you will also study their inverse functions. Make sense, guys?
Priyanti,
Yeah.
what is the inverse of an absolute value function?
The absolute value function.
Yeah, what's the inverse of an absolute value function?
You tell me.
Put it at the lowest.
Is it just the same thing?
Does absolute value function have an inverse? But a good question. I really like it. What do you think? Good question though.
No.
Why?
Like, because its inverse does not pass the vertical line test.
True, but quadratic function also does not pass the vertical line test.
I don't know.
No, what would happen? Yes, meaning the domain, meaning unless you restrict the domain, it's not going to have an inverse. But would it not be y equal to x itself? See, absolute value function, the right side is actually y equal to x, right? Right?
Yeah.
So how can that be inverted?
Oh.
But if you restrict it, what happens? If you restrict it,
You can like maybe.
let's see. See here. This is your, yeah, I already drew. So this is your absolute value function, right? Unless you restrict this, see, if this is your function, if you reflect it on the, this one will become this. This will stay here, you see. So it fails the vertical line test. As is, it does not have inverse. But if you restrict the domain by deleting off this side of the curve, or this side of the function, right? Yes, it does. Basically, this is the function, right? It's its own inverse is what I think. So I have to check though. But yeah, absolute value function can have an inverse only when it is restricted on its domain, just like a quadratic function. Does that make sense?
Yeah.
Yeah. Now I'm going to ask you one or two more questions, please. Okay, let's see this one. How about this? Yeah, you can try this. Yeah, this is a good one. Wow. Okay, this is not an inverse function question, but I would really like you to try this one. F of x minus 3 will be equal to 9x square plus 2. What is f of 5?
Is that my answer?
Shriek. What equation did I give you? Yeah, that is a good question. Let me see. What was your answer, guys? Wow, that's right. That's right. That's nice, Zashvik. Good one. Ritisha, nice. You guys are really good, guys. Diya, nice. Shawanish, please. What is going on? You cannot switch off your video. I told you.
Sorry. I just got the answer.
Then you should be sending, right? You cannot switch off the video in between.
Yeah, I didn't realize it was off.
What is the answer?
I'm sending it.
Wait, Priyanti, is my answer correct?
Yeah, everybody's answer was right. Swarit, where is your answer? Just because I didn't call you doesn't mean that you should not give me.
I'm doing it right now.
How long? Sorry.
I got the answer. I'm typing.
What is the answer? Shout out then. Yeah, that's right. Can I move on, guys? Okay. I think we are good with inverse functions. Okay. You want to do one or two more would be nice. Let's see quickly. Okay. How about this? F of x equal to 2x square plus 3. Find f inverse of x. Can you do that? Finish it. So basic functions you've studied. Yeah, I really want to go through logarithms if possible, or absolute value functions. Let's see. Yeah, special functions, radicals, absolute value, floor seal, rational functions, piecewise functions. Let's see.
I said my answer. I said my answer.
Yes. Good job, Anish. Good job with you. Ratisha, nice. Swarit, nice. Sham, nice. Okay. So you guys are good with this. But you know what? I want to do a couple of things with you guys. Let's see. Okay. Let me see. I want to... Vidyut brought me some questions. So let me quickly see whether I can get it for you. Did you understand the answers, Vidyut, of what you sent to me?
Oh yeah, I understood the answers.
Okay, I really want you guys. How about this? This is something we have learned, I think, before, but I really want you guys to understand things like this. Can you try? How to find this? It's an absolute value function. We did try to solve absolute value function, but here the problem is you have to find all the intervals that overlap. Those are only the answers. So the first equation has two different equations. The second equation has two different equations. Find all the intervals for x where x is valid. Meaning they should all overlap. Whatever overlaps only is your answer. Can you try?
I sent my answer.
Yeah, auntie.
Yeah, ma.
Can I try explaining on the board?
Yeah, ma. Go ahead.
Mhm.
Let me see. Oh, wow. I don't remember the answer, but let's work it out.
I got the answers.
Okay. Anish, good job. Dia, good job. Swarit, did you check it out properly? Ratisha and Ashwik, I'm waiting for yours.
I sent my answer.
Wait, is it like
Good job.
multiple answers or is it just only one?
There's only one answer A,
Okay.
B, C, or
Okay.
D. Ratisha, did you do, ma?
Yeah, I sent the answer.
Oh, why I'm not seeing yours, ma? I'm just waiting for yours.
No, I sent it.
No, I got it. Ratisha, Sham, not really, guys. Vidit, you want to explain? Go ahead.
Okay.
Let me
So
see if you understood.
okay. Wait. Mm, I don't have the annotate thing.
Your login.
Oh, I found it. I found it. So first,
Oh, I get it.
first you solve the two absolute value equations. So wait. Oh, it's not drawing.
It should be able to draw now. Go ahead.
So first you get like 2x minus 3 is less than 5. And then you get 2x minus 3 is greater than -5. And then you solve these and then you get x is less than 4 and x is greater than
2x minus 3 is less than 5. 2x minus 3 is greater than
-1. And then you solve the other two. X plus 1 is greater than 2 and x plus 1
1 is greater than 2. Okay.
less than -2.
1 is less than -2. Okay.
And then after that, you get x is greater than -1. And then x is less than -3. And then after this, you need to figure out which one to make the compound inequality.
Good. So let's find out. X is greater than 4 means what?
X is
This one. This part, right? This one is this part, right?
wait, no, it's x is less than 4.
Oh my goodness. Sorry, guys. What a mess I made. So x is less than 4, right? So then this side, right? That is this. And then what? X is greater than -1. Greater than -1 means this is a 0. Greater than -1 means anything this one, right? Yeah. So from here to here, everything is still whatever answer is should be within -1 to 4. And now this says what? This also says x is greater than -1.
Oh, that's x is greater than 1. My bad.
Yeah, x is greater than 1. See? Okay, x is greater than 1 means it gets cuts off. This is the only solution I have, 1 to 4. And then x is less than -3. That is somewhere here it doesn't make any sense. So the only answer that overlaps is 1 to 4. Make sense? Does that make sense?
I did it a different way.
What is it, Ashwin?
So like what I did is I also found like the value, and I crossed out A because it said 3/2, which is 1.5, and that skips like 1.1, 1.2, etc. So it wouldn't be that one. And yeah, I just checked it didn't work for C because X was only greater than 1. So I got B.
Perfectly makes sense. Can I move on? Okay, I have more questions to you. Let's see this one. Do you know how to solve this radical equation? Radical means the symbol is a radical symbol. Do you know how to solve this? How do you solve this? Can you educate me how you solve this?
For x?
Yeah. See, radical equations, you should be able to solve the basics. See, guys, you guys will find Algebra 2 so easy. These are topics which were reserved for Algebra 2. I'm dealing with, since it is a part of the book and I'm bound to cover the book as well. So they cover some of the basics of Algebra 2. I was keeping quiet, not getting access to this portion of the book just because it was in Algebra 2. But I think you guys can really do this. Go ahead.
Miss Priya, I saw my answer.
That is good to know. Let me see. 6 ayya illaye. Ritisha, I don't think it's an imaginary number. How did you get that? Can you show me how you got that?
A complex number.
You're getting a complex number?
Yeah.
Can one of you show me how did you get that?
Oh, I could tell you because my thing is not letting me draw. But, so like to remove the square root, I squared like both sides, like squared
Yeah,
the
when you
entire
square
thing.
both sides, what happens?
You get
X squared minus 9 equals 4x squared plus 9.
minus 12x plus 9.
Plus 9?
Minus 12x.
Yeah.
And then you get 3x squared plus minus 12x plus 18.
Minus 18.
And then you
Okay.
factor out 3.
Factor out 3.
Mm-hmm.
Okay.
Oh, I see what I did wrong. My bad.
No,
Yeah, I see what
I'm
I did
also.
wrong too.
No, I'm wondering now how did you solve? 18 product is 4. Oh, the
The
sum
discriminator is
is
negative.
4. Yeah.
Discriminator is negative, so you can factor it.
No, I get it. I get it differently. Did we do it incorrectly? Let me see.
I'm getting 2 plus 2 root 2i.
1 second. Ah, we are squaring this. Okay, so what did we get? 4x square minus 12x plus 9. Everything is correct. Okay, after that, so
4
3x
plus
square
minus 8i.
plus 18 minus 12x. Correct. Minus 12x. Correct. No. What? What? You know what? Okay, I gave it to you incorrectly. Okay, makes sense, guys. So you will get a complex number as answer. Huh? Okay, can I please have it like this? If you don't mind. Sorry. I made a mistake there.
Oh, okay.
In giving the question, I made a mistake. So now what happens?
It goes to
Solve
x
for me.
squared minus 4x.
So what happens then? 3x square minus 12x is coming, right? So what happens there? X will be equal to what?
0 or 4.
Good. Okay. But the problem here is whenever you have radicals, right, you should check for extraneous roots. Meaning,
Both of them are fine, I think.
I'll tell you what are they. Please substitute. This is one area where algebra 2 kids all are making mistakes. They forget to check for extraneous roots. When there is a radical or when it is a logarithmic function, you check for extraneous roots. Why? Because you square both the sides of the equation. So you will have to plug this in and check whether your answer is right. Meaning, is this equation working out true? You need to check. I'm sorry, minus 3. So once you substitute 0, it is a positive 3. So it's a negative 3. See, 0 is not a root at all. Did you see, guys? So you can substitute 4, 16 plus 9, 25, 5 plus or minus 5. Now 4, 8, 8 minus 3, 5. So do you see, guys? So what is the only solution? See, this is not working out fine. Substitute a 0 here. When you substitute a 0, this side is a plus 3. But this side, right, when you substitute a 0, it becomes a minus 3 by default. Did you see? So this is not valid. Whereas the next one, right, 4 when you substitute, square root of 25 will be equal to
5.
Yeah,
But
5. So yeah, 5 principal square roots only we are going to take. So this is valid. So the only solution is x equal to 4. X equal to 0 is called an extraneous root because when you plug it back into the equation, the equation is not obeyed. So it is called an extraneous root. Make sense? Hey, this part, whatever I am teaching today and all is part of algebra 2. I want you guys to get at least the basics before you move on. Inverse function is a part of algebra 2. Extraneous roots is a part of algebra 2. Solving radical equations is a part of algebra 2. However, AOP's book goes in depth. I want you to understand. Make sense? Dia, did you get it? Anish, did you get it?
Yeah.
Yeah.
Okay, how about this? I want you to do the exercise values of 20.1. 20.1 you can give it a try. 20.1 and inverse functions, both I want you to do. You can note down, okay? 20.1 and then logarithm I didn't teach you. Next week we'll do 20.1 and then I want you to do inverse functions fully as well. 1 second, guys. Okay, I will put it down, but I want you to do there as well. Alchemist, where are we, guys? All of you? All of you, where are we on Alchemist? Ashvik, where are we in Alchemist?
Let me check.
16.4. Similarly, chapter 16 review problems is such a boon to do. Chapter 16 review problems 16.4 and 20.1.
I have like 20 more topics to cover and I'm done.
1 second. What is that?
I have like 4 topics to cover and then I'm done.
How about the others? At least have you all gotten to a blue bar? Have you all gotten to a blue bar?
For the topics that I've done, yes.
Yeah, for the ones I've done, I have a blue
Yeah.
bar.
Same. For all the topics
Except,
I'm gonna have a
except,
blue bar.
yeah.
Mostly blue
This
bars.
is not.
Same.
Okay, so you have not done it fully. Okay, there's a lot to do. Okay. Okay, how about we allocate ourselves? Do you want me to allocate it as a part of homework? As and when we go through, see, geometry starts, then everything becomes rigorous, right? So you want me to allocate as a part of the homework. Will you guys do till at least the blue bar and come?
Sure.
Yeah, let's do it, guys. I really want you guys to be up to speed with Alchemist as well. Let's see. I think I should have assigned this every week. Okay, let's see. I can share my screen, what big deal.
The topics that I haven't read are the topics that we haven't covered.
Like what, ma?
Like, well, we just did inverse functions, but like exponential and logarithm
Exponential
basics.
we covered, right?
Logarithm basics.
That I need to work on, yes. Logarithm
And
basics I'll work on. Then
then radical expressions and functions.
I really want you to do radical expressions and functions now. You see what I mean? Radical expressions and functions.
Yeah.
Then polynomial basics have you done?
Polynomials basics. No, I haven't. I'm gonna start on that.
See, radical expressions and functions. Can we work on
What
radical
is
expressions
interest
and
rate?
functions this week? Then I want you to cover domain and range. Have you all covered, guys?
Yeah, I have it at
Domain
blue.
and range and evaluating functions. Have you covered?
Yeah.
Yeah.
And then what else?
But there's also quadratic inequalities. I don't remember. I think we talked about it, but I don't know.
Okay, let me. Okay. Quadratic inequalities you have not done, huh? Okay.
Quadratic optimization or something.
Quadratic optimization I didn't teach him. Huh?
And then, yeah, rationalizing denominators. I don't know.
Rationalizing denominators is like root
We
3.
did.
That
We
I
did,
think we
right?
did, right?
Okay.
Where is that
And then
rationalizing denominators?
it's under difference of squares. And then there's also Simon's favorite factoring
That
trick.
I did not cover. See, Simon's favorite factoring trick is usually used in competitive math. I did not do it, guys, with you guys. Okay, certain things I have removed, okay, but very less. Meaning rationalize. So let's target at rationalizing
Wait, Auntie, is inverse
denominators.
proportion easy?
Which one?
Inverse proportion?
Inverse functions. Inverse.
Inverse proportion. Inverse proportion.
Where
Is
is it?
that easy?
Where is it?
It's under direct proportion.
See, when I say x is inverse. 1 minute, Amma. 1 minute. Let me note down these things. Otherwise, I'm forgetting. Inverse functions. So we'll target only at. I will put down these names: radical expressions and functions, evaluating functions, domain and range, rationalizing denominators, and inverse function for alchemists. Can we finish that and come next week?
Which ones?
I can put it in Google Classroom.
Okay.
Can we finish that? But please post a screenshot before you come to class. Make sense? Yeah. Inverse proportions are nothing but see x is directly proportional to y means x equal to y equal to kx, right? Swarit. Inverse function means what happens? Y and x are inversely proportional means y equal to k by x.
Y equal to k by x. Okay.
Y equal to kx means they are directly proportional.
Yeah.
Y equal to k by x, they are inversely proportional. Make sense?
Yeah.
Does it make sense?
Yeah.
Yeah. Similarly, let's say x is jointly proportional to y and z means what?
Wait,
X
what?
equal to k y z. Y is jointly proportional. Jointly means to both the variables. Usually we have only two variables, right? Directly proportional means y equal to kx. Inversely proportional means k by x. When x increases, y decreases. When x decreases, y increases. Make sense?
Yeah. But if it's like, okay, the problem it gave me on Alchemist, it's like square of A and the square root of B are very inversely.
Oh, why do you, meaning, just bring it up to class, right?
Yeah, should I bring it up?
Now, yes. Hey, all the others, if you want, you can log off. He's going to ask some questions.
Bye.
Bye, guys.
Bye, Pranti.
Bye, ma. Swarit, I'm happy you're asking. Go ahead.
It's like, oh wait, should I share my screen?
Yeah, please.
Okay. So it's like this. It's like the square of A and the square root of B vary inversely. If A equals 2 and B equals 87 or 81, then find B1.
Wait. Let's do this. Please, let's do this. Okay, let's do break our heads. The square of A and the square of B vary
Square
inversely.
root of b, square root of b.
Square root of B vary inversely. See, this is what it is.
Oh, okay.
Okay, if A is equal to 2, let's try. B equal to 81.
So k squared, yeah, k by 9.
Okay. B equal to 81.
Find b,
Then
k equals to 2.
find B when AB equal to 48. Okay, AB equal to 48 they have given. Let's see. What are they asking to find? B, yeah?
Wait, would it be like 144? Square root of 144? No.
I don't know. Wait, I'm just working out. Let's see.
Because to get to 48
So
is
K equal to 36, right?
12.
So A square root of B equal to 36 I'm getting. Now AB is this saying, okay, now if I square it, right? A power of 4, then B will be equal to 36 square I'm getting. Now AB is 48 means A cube 48 will be equal to 36 square. What did you get?
Yeah, that. But I don't know what to do after that.
36 times
36 now?
36 by 48 first did you find out?
No.
44, 1, 18, 6 3s are 18, 6 4s are 24, 4, 9, 9 3s are 27. See, A cube equal to 27 I am getting.
Oh,
A will
so
be equal to, just
3,
try
A
3.
equals 3.
Just try 3.
No, it's find B.
Oh, sorry. Okay,
Yeah,
3, then 1, 16 try.
16.
I don't know though. Let's see.
Yeah, it is correct.
Yeah, you got it. That's it. This is how you
Yeah.
do.
Okay. Thank you, Auntie.
Make sense?
Oh, I also won't be here next week, so I'll just watch the recording.
Oh, really?
So,
Okay,
yeah.
ma'am. Okay, but I'm going to cover special functions and logarithm basics. Please
Okay.
watch the recording and
Yeah.
do the alchemist thing, okay?
Okay.
Okay, bye bye.
Bye, Auntie.
Bye bye. Hey, are you finding the classes useful?
Yeah.
We'll go to geometry directly. It'll be a
Okay.
jump up,
Mm-hmm.
but do the homework, please.
Yeah.
Okay, bye bye.
Bye.